Have you ever wondered how plants get their energy from the sun? Plants such as vegetables, potted plants, or trees? Or how we in turn as humans take energy from the things we consume? All life on Earth was originally thought to rely on the sun for life, for energy, for food, for nourishment. But this idea has been changed only recently. On the surface, plants use photosynthesis to produce food, but there is life that does not rely on photosynthesis. This life does actually exist far below the reach of the sun's rays and relies on another life support system altogether. This life is not on the surface, but in the places only the deep sea submersibles can reach. The process of photosynthesis converts carbon dioxide into organic compounds, especially sugars, using the energy from sunlight. This is what sustains plants, algae, and many species of bacteria. Photosynthetic organisms are called autotrophs, since it allows them to create their own food. Photo meaning light, auto meaning self, and troph meaning nourishment. In plants and algae, photosynthesis uses carbon dioxide and water, and releases oxygen as a byproduct to that process. Animals, including us as humans, some fungi, and some bacteria, are called heterotrophs. Hetero meaning another, troph meaning, again, nourishment. In 1977, scientists diving on the Galapagos Rift in the submersible Alvin of the Woods Hole Oceanographic Institute made an amazing discovery that shook the foundations of biology. This discovery of life at sea floor hydrothermal vents reminded us that solar, oxygen, organic matter, and photosynthesis are not the only fundamental building blocks in chemical processes that harbour life. Scientific research of these volcanoes on the subsea environment has led to many new species being discovered, such as tube worms, snails, shellfish, and other bacteria that live around the vents. Since then, hydrothermal vents have been found on the seafloor close to tectonic plate boundaries all over the world. These are the plates which all land masses, like continents, rest, constantly moving, colliding and separating, but at an extremely slow speed. Where they separate, hydrothermal vents appear. Since that discovery, scientists have explored hundreds of volcanic vents in the Pacific, Atlantic, and Indian Oceans. They have found that on the seafloor, as on land, distinct animal populations have evolved in different regions. They support a much higher amount of life compared to surrounding deep sea environments. And a complete food chain, starting with microbes, has been scientifically proven to exist there. So, life does exist at these incredible depths, but how do they produce food? In place of energy from the sun, certain organisms use what is known as chemosynthetic reactions to live and grow. They use inorganic chemicals, such as hydrogen and hydrogen sulfide, rather than organic matter for their energy, carbon dioxide as their source of carbon. Active hydrothermal areas have a number of characteristics that influence the life around them, the most important being the chemistry of the fluid emitted from actively venting chimneys. Geothermal, rather than solar, energy catalyzes these chemical reactions that generate these life-sustaining chemicals from rocks and seawater. Water is the only absolutely essential ingredient in the process. Instead of photosynthetic plants, chemosynthetic microbes comprise the base of the food chain at these vents. The food chain starts there, and so a complete ecology is made. The areas in which these ecologies thrive are surprisingly hot. Vent temperatures covering a range from a few degrees above ambient to 350 degrees Celsius. Microbial populations can survive in temperatures of up to 121 degrees Celsius, so there is no shortage of heat to sustain the inhabitants there. After the abundance of life was found in conditions that had been considered too extreme, it changed the view of the places and circumstances that can harbour life. In recent years, scientists have discovered many new subsurface biosphere habitats, and in all these places, species have adapted to extreme conditions that include high pressure, high and low temperatures, unusual or toxic chemicals and minerals, or low availability of essential nutrients. Once again, nature has prevailed in producing life in these extreme environments, much to our surprise as humans.